Really excited to be here. And what we're seeing with Accenture is a lot of excitement as well. And actually, Reg makes a great point about this $1 trillion market. Where is it exactly? So we'll spend a little bit of time talking about that. The really kind of 5 things I'm going to squeeze into 20 minutes. So we're sort of going to hit the top of the waves here. Is a little bit about the state of the IoT market. I'll give you some context around that. What's happening with connected devices and data and the growth that we're seeing. How is AI manifesting itself as an enabler for IoT? So this is really that intersection. And how are we seeing that start to evolve? Whoops. Also, one of the core problems that we're seeing is there's a lot for AI to learn, a lot to be able to really get a lot of value out of IoT. And then lastly, what do companies need to do, particularly enterprises that are looking to leverage IoT and AI together? What have they got to be able to do to really get the value from it? So I'm going to start with a little bit of perspective and context. So one of my first jobs out of university was actually doing data acquisition for an IndyCar team. That's Nigel Mansell, who was a British racing driver, backing into the wall at Phoenix in 1993 at 185 miles an hour. We had this incredibly expensive telemetry box on board this car. It had about 100 hertz sampling rate. I think it could do 64 channels. We had about 45 active. So we were consuming about 5 megabytes per hour. Didn't need a lot of hard disk product. And really what was interesting about that period of time is, and after this crash happened, they wheeled the car over to the pits, and it was just this crumpled wreck. Still had power on it, so I was able to download the data from the car, and we were able to actually diagnose a couple things that happened during the accident. That he went light. There was an increased aerodynamic force in the front wing. Back end spun out. We were able to see a lot of that performance, and over the course of the next 3 or 4 months, which is a very short time, but in auto racing, you work quickly in product development. We were able to do some design changes to help improve the stability of the car. It was very historical. It was driven very much off of a bulk of data, almost batch mode, seeing what's happening, getting what insights you can from that data and trying to reapply it to driver insights as well as to engineering design. Fast forward 10 years, there was this golden period of IoT in Formula One racing. For one season, Formula One allowed for 2-way telemetry between the paddock and the car. And the Ferrari F2002, that's Schumacher driving, dominated the field. And what they were able to do is actually, they had about 100 channels. They were sampling at about something like 400 hertz. Collecting about 100 meg per hour of data off the machine. But what they're actually able to do is to start to take a look at near real-time activity and performance of the car, and could actually send commands back to the car to change fuel mixture ratios, et cetera, right? So it became this period of time where we had near real-time responsiveness to what was going on inside of the car. But it was still very reactive, and it was deterministic models that were being used to understand what was really happening and what could change on the vehicle. Fast forward to today, just back in, I think it was May, NIO, which is a company right up north of here, kind of not too far from Cisco, the EP9 actually went on and at Hockenheim, I believe it was, and came fairly close to, it broke a record for the fastest electric car ever on the track. But it's a fully autonomous driver. That car is collecting on the order of about 5 terabytes per hour of data. Now, I couldn't quite get 10-year segments here, but in 15 years went from 100 meg an hour to 5 terabytes an hour. And because of the resolution of data they're able to capture, they're able to actually execute autonomous decision-making at the edge, right? So I like to talk about cars and autonomous driving, not because it's cool, which I happen to think it is. I'm a bit of a car guy. But because I think there's a lot for enterprises and people to learn about what's been happening at the pinnacle, at the forefront of racing in particular, because I think enterprises can go through this path. And being able to do predictive and autonomous calculations through AI is something that we can all learn from. And what I would say, and by the way, is anybody here in autonomous cars or auto? Okay, a couple. So I'm gonna pick on you a couple times through the course of my presentation. But what we have seen is that most companies that have implemented IoT in the enterprise are somewhere near the middle of this trajectory. They're collecting data. They often don't know what to do with it. They may have some infrastructure in place to pull it together, but in order to really take advantage of it and do it at scale, they tend to not have quite a high enough resolution to be able to actually project and forecast and predict. And so I want you to kind of keep this context in mind as we talk through this topic today, because I think there's a lot of insights to be gained from the trajectory that they've gone through. So the state of the market. Economist did an interesting study. I think this came out in the fall of last year, so it's dated by internet terms, but it's still pretty insightful. 19 out of 20 executives. These are all C-level executives that were surveyed, and it was actually equal. I think it was 300 each, North America, Europe, and Asia. And 19 out of 20 expect that they're going to be using IoT within the next 3 years. 3/4 of them said they were actually exploring it today, looking at what they were going to do, but only 7% actually had a strategy about how to utilize it in the enterprise. I actually have the data on this IDC piece on the bottom because it's so amusing to me. This is a 2013 analysis by IDC. So this is the forecast from kind of last year through to next year. You'll notice a little bit further over this. So they were projecting a linear growth of 30 billion devices. A current forecast is about 50 billion devices by 2020. And why is this happening, right? If you look across the top, everything has been doubling either in speed performance or in cost reductions. Sensors is actually one of the more interesting ones. The evolution of MEMS and the ability to put very high-resolution sensors at very low cost into different devices is one of the things that's actually driving the most recent evolution of IoT. But processing costs, storage costs, where the data is coming from, even smartphones, just from an overall data growth perspective, is an important factor in this. And so at the end of the day, 31 exabytes is the expectation by 2020 of just mobile data traffic on mobile networks as 5G gets deployed, et cetera. There is a huge uptick in expectations, to Reg's point, about where this is going to go. One simple example is just looking at the growth in resolution of the information coming off of cameras on devices. Right, there's a couple curves here as examples. DJI Phantom drone is now collecting about 500 megapixels per second of information. Quite a big spike. The important thing about resolution is the greater resolution you have, the more computation you can do, particularly around predictive analytics. And this is just one of a number of kinds of examples that are typically consumer-oriented, but they're a good metaphor for the kind of growth that we're seeing in sensors and IoT technology in general. Now, one of the big reasons that we've seen IoT is not getting as adopted as quickly in enterprises as many of us might hope is a platform challenge, right? It is complicated to stitch this stuff together, to just connect to, activate, provision, collect data from, ingest, and analyze information coming off of all of these sensors. And so, this happens to be sort of a number of different components flying around the world. But if you think of it from a connected city or connected home, just the sheer act of building the infrastructure to get information off of these devices is a significant amount of work. And what we're seeing is most companies are focusing on, all right, how do I get this built? However, what a lot of companies are not yet able to really focus on is that the data is truly what's going to drive the value here. And much more energy is being spent figuring out just how do I get it, and much less on what do I do with the data. And in fact, we spent some time talking to clients who are saying, well, I've already got data I'm getting from some of my stuff, and I don't get that much value out of it, so why would I go get more data? Why would I spend more on infrastructure to get more data? And it's a pretty common refrain that we hear. And so, we've got a whole other discussion we can have around platforms, but the data itself and what you can do around it, we're finding smaller mechanisms, smaller ways that companies are starting to address AI through what infrastructure they can build without having to necessarily deal with all the complexities of the broader architecture. So a couple examples of what companies are doing. Uber, you got to kind of talk about it, but what's interesting about Uber is that they haven't just been focusing on autonomous driving, but they've also been focusing on finding ways to use AI just to match supply to demand, right? How do I make sure that I've got enough cars in a certain area in a certain time? Right? They can actually use AI to start to project where there's going to be high demand, get more cars from out of region. That's when you see your rates start to jack up if you're using Uber. And so there's a lot of capabilities that Uber's been utilizing because they've got a lot of geospatial, they've got credit cards, consumers, a lot of data that's gotten them in trouble. But at the end of the day, it's actually been very helpful to drive a lot of growth and to be able to utilize AI in very specific ways to benefit the consumers. I think a really compelling example in what I would call old, heavy iron, what some people think of as less interesting industries, is what Siemens has been able to do. So not only have they done AI and autonomy at a machine level, but they've actually been able to step back and apply it at a factory level. And it's an interesting metaphor for sort of systems thinking here, that AI can be applied at multiple layers of abstraction. And what Siemens has been able to do is actually start to drive self-governing, self-organizing factory capabilities. You might have heard of Tesla's actually is planning to do something along these lines as well to implement essentially a fully autonomous factory. Improve capabilities, improve safety, and be able to sort of run itself. And so these levels of sort of abstraction up, this is a good example with Siemens where they've been able to do it. Now Siemens has solved the platform problem because they are a platform company as well. So they've been able to integrate all of their Siemens technology through that single platform and focus on the AI. But these are two very good examples where they've been able to do things like that. So how can AI be an effective capability for IoT? One of the core things that we're learning is the ability to train AI becomes an important obstacle and something that's not accounted for a lot with our clients and what they're deploying and what they're going to implement. In our dialect, the ability to sense, comprehend, and act is really what drives sort of the end game of AI, the ability to do autonomous thinking and being able to make sort of assertions at a local level. And what we're finding is that the deployment activities, at the end of the day, in AI, the data and the ability to train the system is the same, if you think back in sort of procedural language, is the same as coding and testing a system, right? And you have to have the same amount of rigor, the same amount of focus on having the right kind of training data, enriching it in the right way, utilizing tools and technologies to be able to make that happen. And this is an area that's evolving fairly quickly, but there's a lot of great opportunities for companies to utilize crowdsourcing. We've got some partners that we've worked with in the past to help do things like this. So, what does AI have to learn? I apologize, I had some specific notes on this one I wanted to be sure to hit on. The further towards the edge and the more unpredictable of an environment that IoT is being deployed into, the more important it is for the AI to be trained in a way that can be autonomous. And what that means is, as you're training an AI solution using IoT technologies, you need to be able to have a comprehensive enough data set to be able to enable the AI system to recognize certain kinds of patterns. There's a good example in social media where there's we'll say a software company that deployed an AI bot onto social media, trained it on feeds from largely teenagers. You may have heard of this. They had to pull it off the market within about 2 days because it learned all of the bad social mores of teenagers and started using profanity and racial slurs, and it actually was a success technically, right? I mean, it truly learned from the data that it was given, but the training that was performed ahead of time, it was not cleansed well enough. The types of behaviors and performance that they wanted to achieve weren't necessarily incorporated into the training data, and so the results became unpredictable in the context of what was desired, but it was actually very predictable in the context of what it was fed. Right, and so this is that factor as enterprises are going to deploy IoT and want to be able to make decision making on the edge. They've got to be able to resolve this and address it. The ways that we are seeing some companies address this problem is by starting very small and starting in kind of safe zones. AI can be trained to explore, but exploration is dangerous. And this is sort of the example with the social media concept. However, where companies are sort of drawing a box and having a lot of human interaction is sort of an initial deployment of AI. They're seeing a lot of success, right? So the human can start to recognize where things are going awry. And so the sensitivity to the initial training can be mitigated through that kind of a construct. However, if it's going to be a little more untethered, and the level of autonomy goes up in a more uncontrolled environment, it's a significant amount of activity that needs to be structured around what I would liken to a develop, test, deploy methodology in old school systems building. And so there's a lot of balance between how much human interaction and intervention needs to be accounted for in the deployment of AI and how much of the training data you're able to actually build. So some examples of companies that we're working with are companies that are actually enabling crowdsourcing of enrichment of data, right? So if you have a solution that's using visual video information, how do I know what's a cube versus what's a rectangle? And having humans that are able to actually enrich that data and do it in a crowdsourcing mechanism is a very cost-effective way to make that happen. And so deploying those kinds of technologies in the evolution and development and deployment of the AI system is a really useful way that we're finding an ability to get much richer data, much faster learning, much more quickly. And where we see this headed, I'll go back to Tesla, is as IoT is out in the field and AI has been deployed, we now have a mechanism to collect even more data. And as we're pulling something between 20 to 40 terabytes of 8 hours worth of driving, we're getting real-time or near real-time information about what's happening out in the world. Are there road closures? Is there a new pothole? Has the speed limit changed someplace, right? So the sensors out in the field are actually able to collect even more data to enrich infrastructure, to enrich kind of the information back in the cloud, where new rules and new AI networks can actually be redeployed. Or just the source information about the regional area. So in autonomous driving, what is actually in the area where I'm about to go drive. The ability to have IoT out in that environment, collecting even more data, makes an even richer experience that can provide improved product capabilities for the product that's been deployed with that solution on top. So what our perspective is there's really three things that companies got to be able to do to get AI training right in an IoT environment. The first one is thinking through the training process from the outset. Right? This is a really key aspect to AI. It's defining the right data, defining the enrichment process, defining the verification process that the training is happening in the right path, and then having a deployment approach where you can actually verify that the performance will continue to evolve in the right direction. The approach used, the methodology number two, is being able to have some of the right mechanisms that are able to enable the constant refinement of that data set and of the patterns that are being codified into the AI system. Right? How's the enrichment going to work? How can we leverage crowdsourcing? How can we leverage more procedural models that might already exist or heuristics that we have to become sort of the backbone of the AI training? And what do we have to have in place to make sure that nothing goes off the rails? So as we go to deploy for the first pilot, how do we make sure that we don't end up with swearing teenager bots that are driving interactions? And then lastly, the business model. So there's some really interesting opportunities in the marketplace in starting to create data sets that can be used as the baseline for training. We're starting to see a lot of this in geospatial. We're seeing a lot of at least alliances around autonomy that are starting to try to build their own repository of training data, global training data, to be able to enable auto manufacturers, for example, to deploy it more readily and sort of have the starting point that they can enrich themselves. So there's a lot of interesting business models around that, around potentially using open source frameworks. And then also longer term, when a company's product is out in the field, how can the data that it is in turn collecting also enrich the broader data set and be utilized for future products and for other products that are not in that same space. So, very brief, I mentioned I was going to kind of skip the top of the waves. We do have a white paper that I think if this is distributed, you can click on the link. Otherwise, we created a bit.ly link for it, so you can download that. Feel free to reach out. I'll be around afterwards if you want to chat.